Hello all. So today we are going to see about the important topic, which is what do you call the torsion. So generally we know that the torsion is nothing but there is some opposite twisting moment of a shaft, or there is a sudden change in direction. The force applied in opposite direction, which may either in twisting in two different direction of rotation. So because of that, the torsion has been produced, but this unit, which is entirely deals about because of the torsional load, what kind of stresses which has been induced in this shaft, and in that shaft, what kind of stresses has been induced, and how can we analyze the stresses for these cases. So these are the major things that we are seeing in this unit 3, that is what you call the torsion. Okay, so that is what here it was stated, like torsion is the moment which has been applied in a plane containing the longitudinal axis of the beam or the shaft. The shaft transmitting the torque or power, it beams the portico beams or curved beams, which has been used in so many format ways. Okay, so this images which shown the torsion moment. Here you just take a case study of these two different conditions. One is called this torsion, which may occur in many different kind of form. Either the shaft which has been rotate with the help of the torque. Because of the torque, what happened, there is some displacement which has been induced in that axis, and whenever that we are applying the torque, there is some internal resistant force which has been produced. So that has been exist in the opposite direction of the form, that is what you call that internal torque. Okay, and in the third row we just go and say about this torque has been variation in the shear stresses. So this shear stresses which may point out in the cross section, and along with the angle of the twist, we are putting the efforts to find out their torque variations. Okay, so that is what here it was described in this diagram. And for studying about this torsion condition, there are some assumptions which has been made to analyze about the torsion. The first one, the material of the shaft which has been uniform throughout. So that is the first condition. If I am taking the shaft for analyzing the torsion, this torsion has been assumed based upon the first condition, that is material it should be in uniform throughout. So that is the first one. Following that, the second one is the circular section remains circular, which has been even after the twisting. Okay, so when I am giving the twisting force, this circular sections which has been remains circular. There is no shrinkage in any kind of direction which has been present in that shaft. So that is a second condition. And the third condition, we need to take the stresses do not exceed the proportionality limit, which means according to the Hooke's law, the stresses never disobeys their Hooke's law. It should be in within proportional limit. So that is the important thing. So proportional limit is the category which has been present before it attaining the yield limit. The material has been expanded up to the proportional limit, and the shaft is loaded by the twisting couples in the planes that are perpendicular to the axis of the shaft. So that is very important. For example, if the shaft is loading in the plane sections, it should be a remain plane and do not twist or warp. The twist along the shaft, which must be uniform, and the distance between the any two cross sections which has remains in the same shape of the shaft, which has been obtained. That means there is a no twisting warp which has been present. Okay, so based upon these assumptions we are need to solving the torsional problems. Thank you.